Hello, my name is Michael Mitchell. I've been a high school mathematics teacher at J.P. McCaskey High School in Lancaster, Pennsylvania for over 30 years. I also served as an assistant basketball coach for 29 years and currently lead Mr. Mitchell for Mathematics, Inc., a nonprofit focused on increasing engagement in STEM learning. My interest in STEM education stems from a passion of showing students how math and science are not isolated subjects, but tools they can use to solve everyday problems. That philosophy is at the heart of a program I created called Pool School, which I'll describe later. STEM in my classroom? In my classroom, STEM comes to life through Pool School program. This activity engages students in applying geometry and physics to analyze billiard shots. Students examine concepts like angle of incidence, ball trajectory, and friction, then model their predictions using software simulations. They collect data, calculate optimal paths, and refine their approaches, bridging abstract math with hands-on experimentation. This activity allows students to not only visualize mathematical relationships, but also to communicate findings in debate strategy, mirroring scientific engineering practices. Referring to the Vasquez chart on page 38, the project embodies multiple integrated practices. From science, students ask questions like, what happens if I strike the cue ball at this angle? And from engineering, they define problems such as, what's the best shot to sink the 8-ball under current table conditions? From technology, they use new tools, including apps and simulations to predict ball movement. From mathematics, they make sense of problems and persevere in solving them using slope, distance formulas, and geometric reasoning. This integration exceeds the sample Mars example from the chart by placing students in the driver's seat of inquiry and iteration, directly applying multiple STEM practices to the familiar real-world system. STEM education is essential because it develops transferable skills like critical thinking, collaboration, and creativity, all while connecting classroom learning to real-life applications. The framework for K-12 Science Education 2011 highlights how science and engineering practices promote understanding of core ideas, cross-cutting concepts. When students engage in tasks like Pool School, they aren't just learning content, they're learning how to think like scientists and engineers. My goal for this course: 1, to sharpen my understanding of integrated STEM practices so I can revise and improve my curriculum accordingly. 2, to design NGSS MPA skills aligned lessons that are student-driven and inquiry-based. 3, to increase access and engagement in STEM for historically underrepresented student groups, making learning more equitable and culturally responsible. In closing, thank you for taking the time to learn about my STEM journey. I'm excited to collaborate with all of you and to continue growing as a STEM educator, grounded in theory, practice, and purpose. Here are a few of the Pool School pictures that show instruction, they show success, and they show a group of individuals committed to wanting to get better all the time and using STEM. Thank you.